So we are going to start Unit 2 today. I have mapped out all of Unit 2. You will start, not only will we start a new fresh unit today, but we're kind of getting into that, and I say kind of because next week it kind of gets screwed up again, because we've got that virtual learning day next week Friday, week from this week Friday, no, wait. But I'm looking at this week Friday, you'll take a formative assessment in class. The homework that you get today will also be due this week Friday. So what I had started saying was, we're kind of getting into that routine now of, you get a homework on Monday, it's due that week Friday. Okay? And then there's on that Friday, then there is some kind of an assessment. This week it's formative. The formatives are the ones that you fix. Okay? Next week, then, because of the virtual learning day, we have something extra special for you to do on said virtual learning day. And then the following week, so this would be the week after homecoming, that's when we're going to take the Unit 2 test on Friday, October 6th. 2 tests. Okay? So, just know that. That's the 3 Fridays coming up. Okay? Ooh, somebody from Hill's Corner, Wisconsin, is calling me on my wrist. I don't know them. So, no. No. So chapter 2 will cover a wide variety of linear type things. So we're going to get into some relations and functions today, and then the rest of this week we'll be dealing with graphing lines and finding the slopes of lines and all of that fun stuff. Next week we'll get into graphing absolute value equations and writing linear equations, so actually giving me the actual one, and then we'll finish up with graphing inequalities, linear and absolute value. So linear unit, this, or Unit 2, is a linear unit. Okay? So a relation is a mapping or a pairing of input values with output values. Okay? So it's a linear relation that matches inputs to outputs. Okay? There's 2 parts that you're going to probably, I don't know if you'll have an audible groan here pretty soon, or if it'll just be an internal groan. But there are 2 parts to a relation. There is the domain of a relation. That's your inputs. Right? The domain is your inputs. Typically, in math, the domain is the x values. It's the it's the independent variable. It's what you're putting into the function. And that's going to be your domain. And then there's the range. Okay? The range is the output, what comes out of the function. That typically is our y values. Now, for us right now, we're going to, in our relations, we're going to use set notation. Later on, we'll get to, usually it's the end of November-ish, we'll get to where we don't have to use the set notation, or we'll just say all real numbers but this, because there's too many numbers to write down. Okay? Now, I think these are technically called braces. Okay? They're not brackets, they're not parentheses. Okay? I think technically they're called braces. I can't draw them. I can't. I just can't. So instead, what I do is I write what I call I have come to grips with the fact that I can't draw the right side. The right side hurts. Can't do it. Looks too much like a 3. Left one I can do just fine. Right one I can. So if you need to do squiggles, you can do squiggles. Okay? One thing that I will say about both the domain and the range is that we don't repeat any values if we are writing it out. Okay? So we don't repeat the values if we're writing it out. There can be repeated values in the domain and in the range. Yes, but we just don't, when we're writing it out, we don't write down like -4, -4, 5, 5, 7 as our domain. Okay? We don't do that. Okay? Now, there are 4 different ways that I will have you, or that we will have you, represent a relation. Okay? So here are the 4 different ways. Okay? The first method is you can write it out as a list of ordered pairs, or an equation. For the example that I did, because I'm going to do these 4 points, I'm going to show you in the 4 different ways. Okay? So that could also be, instead of writing it out as an ordered pair, later on this week, we're going to write it out as an equation. Okay? The next way that you can represent a relation is with a table, an XY chart. Now, I don't care if you go vertical with your T-chart or you go horizontal with your T-chart. I don't care. Okay? But just know you got to have it labeled as to which one is which, and typically we do X's on top or X's on the right column. Okay. And so on and so forth. Okay. Same again. So in the table, 4 is paired with 2. That would be the 0.4, 2. 3 is paired with -1. That's the 0.3, -1, and so on and so forth. So we have all of that. Okay. Next way is everybody's favorite, and that is a graph. We could graphically represent this relation. And we would map out where those points are on our Cartesian coordinate system. Remember, with X's are there, Y's are there, positive is to the right, and positive is to the left. Okay. So that's a third way to represent a relation. And the fourth way you might not have seen. Okay. So the fourth way is called a mapping. And a mapping takes all of the elements of your domain again, we don't repeat them because you see there's 2 positive 4s in our domain. The domain is our X values. So in this column, there are 2 positive 4s. And we only write one of them. And then we also have our range. There's repeats. There's a repeated of -1 in the range. You write it once in a mapping. And then you draw arrows. So the point 4, 2, so this point is an ordered pair. In the table, it's there. On a graph, it's there. And in a map, it's right there. So that's 4 different ways of representing the same thing. Now, a map is limited. You wouldn't, if you had an equation, you wouldn't do a map because your map would be ginormous. Okay? Probably also wouldn't do a table or a list of ordered pairs. Give me the equation there for it, and you would probably be limited to graph on that one. Okay? So, find the domain and the range of the relation, and then draw the mapping of said relation. Okay? So my domain, typically we label our domain with a capital D. I know the math folk got really creative when they said, oh, let's label domain with D. Exactly. Okay. Then we've got to do our set notation. So that's our braces. For me, that's a squiggle. Okay. And then we're looking at domain. Is that X values or is that Y values? X values for domain. So that would be, do we have any repeats? We got 2, 5, -3, and 8. No repeated numbers, so we can write them out. Now here, ideally, you would write them out in numerical order. But I'm okay if you don't. If you just literally give it to me left to right, that's fine. I'm okay too. But ideally, you would put that in numerical order. Range, I know, stepping outside the box here. Range is going to be a capital R. Any repeated values in the range? 7 is repeated, yes. Henry, shaking his head. That's not right. Yeah. So we only have to write that one once. Okay? So we only have to write the 7 once. Even though it shows up twice, that's fine. We only have to write it once. Okay? So now my mapping then, so I would take the elements in my domain, -3, 2, 5, and 8. If you put them in an oval or a box, I don't really care what you put them in. You don't even have to put them in anything, really. Okay? And then you've got the elements of your range, -1, 4, and 7. And then you are going to draw, so 2 goes to -1. You draw arrows to them. 5 goes to 7. -3 goes to 4. And 8 also goes to 7. So that would be the mapping then of this one. One thing I failed to mention back here is if your list is a set of points, if your graph, like this was just a set of points, do not connect them. You only connect them if you have an equation. If your relation is a set of points, leave them as dots on your graph. I forgot to mention that before. It popped in my head. Okay? All right? So a function then is a special kind of relation where each input has exactly one output. Okay? So the inputs are only paired with one output. Meaning, okay, there are no repeated or no repeats in the domain. Okay? So your domain, your x values are all different. Okay? That makes it be a function. If your x values are all different, it is a function. Function, not a function. So you're looking at the domain. So you're looking here, 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 and here. Any repeats in those values? No. So therefore, this relation is a function. Function, not a function. Why not? -1 is repeated. We got a -1 here, and we've got a -1 there. So this one is not a function. Now, you've dealt with functions before because I know that you know this next slide. Okay? How can I tell if my graph is a function? Vertical line test. Okay? You can use what's called the vertical line test. And so a vertical line, you take any vertical line, there's my vertical line, okay, and you slide it across your graph. Now you have a wealth of vertical lines. You have pencils. You have sides of phones. You have water bottles that you could just roll across because the edge of the water bottle when you're looking at it is still vertical, or straight, I should say. Okay? Your hand, okay? If you tuck your thumb in, your hand is semi-vertical. Okay? All right? So you can do all of those. But you take your vertical line and you slide it across the graph. Now, if your graph, so if blue is only ever touching red in one spot, it's a function. So this left one, is it a function? Yep, that's a function. Okay? So that one's a yes. Middle one, function. I would say yes. Yeah? I would say yes there. Right one, function. I would say definitely no, because right there it's touching 6 spots. Okay? It can only, blue can ever only touch red once. Okay? So that one is a hard no. Okay? Touch that at 6 spots. No? Alrighty. What we got underneath? Put a shade on here for some reason. Oh yeah, vertical line test. It just tells us what the vertical line test is. Okay. Yep. So the VLT. Love it. Okay? So we can then also evaluate functions for any value of x. For instance, what I mean by that is, here is a function. Now this is function notation, f of x. Okay? So we have a function whose independent variable is x. That's what that's saying. So f of x here is defined as 3x minus 4. Okay? We want to know what f of negative 2 is. So we replace any x in our function with negative 2. And then we just do that math. Okay? So 3 times negative 2 is negative 6. Negative 6 minus 4 is negative 10. So f of negative 2 is negative 10. Okay? We're replacing negative 2, or excuse me, replacing x with negative 2. You find me h of 4 and j of positive 2, please. H of 4, j of 2. So this is going to be 2 times 4, which is 8, then plus 6. So I get here that h of 4 is 14. Agree with 14. Yeah. Okay. This is going to be 3 times 2 squared. Oops, tap the brakes. That should have been color coding. 6. So 2 squared is 4 times 3 is 12. 12 plus 12 is 24 minus 5 is 19. Agree with that one? All right. Love it. Oh, my Lanta. Is that it? Here, I thought we had one more slide. Oh, that is it. So, today then, you're going to be getting the week 2 worksheet. Or, excuse me, not week 2, week 4. We're on week 4 already. You'll get the week 4 worksheet today. The best part is there's nothing on here that has relations on it. Okay? There's some graphic stuff. There's some drawing lines. There's some determining parallel, perpendicular, neither. So, you don't have homework tonight, technically, but you can try this stuff and see what you remember if you want.